Hi, good morning everyone. My name is Arvind son of Segren and we are from group 5, and today we are going to explain about whirlpool turbine system. So let's go to the introduction. A whirlpool turbine able to provide energy throughout a day for thousands of homes. This turbine can produce a low-cost power solution for rural areas. The generator uses flowing water to provide energy to power up to 60 homes. It has a long lifespan and requires lower maintenance, which means in this whole system, only the turbines makes the rotation movement, right? So we need to handle the turbine carefully so that it requires a low maintenance. The last one is this turbine can produce as much as 10 megawatt in power output, which can power up a small city. The second one is working principle. So first is a hole is dug near the water source to install a concrete basin from a prefabricated part. Second one is a generator and impeller are installed in the basin, the center of the basin. Third one, the water flow through a straight inlet, and then water flows into the basin and a turbine withdraws the rotational energy. The last one is it able to convert into electrical energy. So back to the first slide, as the image right there, it can explain how a whirlpool turbine works. Okay. Initially, the wall is lifted up, right? So the water from the river pass through the inlet to the basin. So as the water rotates inside the basin, it creates the vortex. Okay. As the vortex rotates the impeller, it creates the energy, rotational energy, so which will convert into electrical energy with the help of generator. So as you can see from here, as the reduced speed of the turbine, it is ensured that most of the fish can pass through this turbine without any danger. Okay, this is much more difficult to achieve in a normal hydro plant. So I think this is the best turbine system for the rural areas. Thank you. So the next slide will be about literature finding, which is explained by my partner.
Okay, good afternoon. My name is Muhammad Al-Haikal, and my matric number is 197273. I will tell you about the literature finding of this project. Okay, from what we have done our research, we find that there is a company that is doing the whirlpool turbine, which is named as Turbulent Hydro, that comes from Belgium. The model that they are producing can generate about 50 kilowatt to 100 kilowatt power that normally can produce energy to enough for city homes for their largest model. And the models that they are doing do not harm the ecosystems, like what Arvind has said before, because of the turbine, and the turbine also have a low pressure. And this whirlpool turbine that they are currently producing also need less maintenance, because the only thing that they're working is only their turbine. So they only need to change their turbine if there is any error with the turbine. And also the installation of the whirlpool turbine need almost 1 week to finish. Next, I will pass out to my partner.
Thank you, and good day everyone. So today I will talk about the theory of turbine. So here the theory of turbine is about the how the movement of water and movement of the vortex. So from here, as the first thing we're going to talk about is the flow of the water. When the water is going in the flow path of the turbine, the water will move as fast as possible. So it's like in very high velocity. So when you come to the turbine or generator part, it will start to rotate the turbine in a very high velocity as the initial movement or velocity of the water. So when this come to the turning of the generator, so the center axis will facing a very low amount of pressure because there is a very high velocity of movement of water. Then this vortex can happen at the mixed axis of center. Besides that, the mixed axis center where the vortex will occur, it start to increase the vortex movement along all the bottom of the basin of the water. So this is how the theory of turbine, the water movement and the speed of the velocity of water that is going into the whirlpool turbine. Next slide. So here the introduction to the vortex motion. So I'm going like where it's like the water movement. You can see the water is turning. So this can easily form a movement. I mean the vortex formation. So from here you can see this. This is the simulation, 3D simulation of this video. It's about the vortex circulation. Okay, so now we'll come to the vortex motion of whirlpool turbine. So as we all know that the vortex motion of is actually a part of the movement where it forms from the velocity of the water. So when it's a very high velocity of water, the vortex motion will occur very easily when it's come to the turbine part. So you can see here, there is a lot of concepts whereby turbulent, laminar, and transitional flow, right? So this one, the turbulent flow, will make a law in making up of the vortex circulations or swirling up of the water movement. As you can see, the water movement also from the generator, it goes down into the lower part of the basin. So when the lower part of the basin at that area, the circulation of the vortex motion is very can be seen clearly because the movement of water come to be very sharp pointed end. So it start to recirculate back the water to the river or to the reservoir. So from this slide is going to talk about the conceptual studies of the whirlpool turbine. So the conceptual studies of the whirlpool turbine is like where they're part of the area to be digged up to put a turbine and generator to create a whirlpool turbine, and also the concepts of vortex motions, and also there is the limited area where the turbine can be positioned up to create a great amount of energy generating, or we can say that power generating to give the power or to transfer the power to the isolated area. So from here, the slide I talked about just now is about the power generating, and here is like you can see the movement or the flow of the power generating from the whirlpool turbine. So when the water in, the power generation will occur here when the generator or turbine start to move, swirling up. So when they're swirling up, when the high amount of velocity on the generator, it will create a high sprouts of water out. So when high sprouts of water out means is a high amount of power being transferred or being formed. So I think that's all for my part. So I giving up to my partner to talk about the next slide. Thank you.
Thank you, Ignis, for the pleasant presentation. So I'll be talking about the 3D modeling and designing of this design. So this is the 3D design of the whirlpool turbine that I have done using CATIA. So as you can see from here, the design is quite unique. The basin is designed in a way to create a whirlpool. So the whirlpool, let's say from here, then let me explain part by part. So firstly, as the water enters, you can see there's a automatic slide gate. And this slide gate, the function for it is to control the flow of the water. So as the water comes, because as you can see, there's a limited amount of area for the water. If overflow of water has been inside the basin, the water would overflow and vortex cannot be created to move the turbine. So that's the reason for this automated gate. Next, when the water flows into here, as you can see, there's a curve right here. The reason for this curve is because we want to create a vortex. We need the water to move in a circular motion to create that whirlpool, that vortex, just like my friend explained. So as the vortex is moving, it will create a whirlpool, and the whirlpool, as we all know, a whirlpool and a vortex is directed downwards. It doesn't go sideways, it doesn't go left or right. So we need to direct that whirlpool and motion downwards. For that reason is why we made the turbine to be below the vortex. So as the vortex moves the turbine, as you can see, this yellow rod will be, as you can see, on top of this yellow rod, that's where the generator will be. The generator, as the water moves in a vortex motion, it moves the turbine, and the turbine will generate as the movement of turbine, which makes kinetic energy, and the kinetic energy will be able to move the generator, and the generator will convert it to electrical energy. So as you can see from here, our turbine design is only 5 blades. The reason why we use 5 blades, and the blade is actually not, we didn't design our blades to be sharp. So it needs to have a curve design. So the reason for this, like my friend said in the introduction, we designed our turbine to have only 5 blades because we want the small debris can able to pass through, and also small aquatic life also can pass through unharmed. For this reason is why we made only for a design of 5 blades, and there's a big amount of space for this kind of small aquatic life and also small debris to pass through. Okay, as you can see from here, as the water goes, the vortex will be towards downward and moves the turbine. Okay, next. Okay, this is the front view, top view of the design, and this is the side view of the design. As you can see from here, as the water moves, it goes into the vortex, circular motion, and goes down into the turbine. Next. Okay, and this is the front view, and the front view is where you can see where the water is directed. As the water is going towards downward, this is where the water is directed out. As the water goes down, the debris, and even a small aquatic life is directed outwards from this. And there's only 2 types of material, that is, about 3 types of material being used for this design. First is concrete for the basin, and also to direct the water out from the basin. Next would be the turbine. The turbine is made out of cast iron on stainless steel to avoid corrosion, so that it would last longer, and also the automated gate. And also the turbine can also be made out of carbon fiber to last longer. And this design is actually predicted to last for about 100 years, and it's in a small scale, but it can be done bigger. It's done in a small scale, but it can be done bigger for rural areas and for people who are living near the river. Thank you. That's all for today for my 3D explaining of the 3D model. Now I would like to invite my friend Ani to explain his presentation. Thank you.
Thank you, teacher. Okay, so first of all, my name is Hani Abdullah Nahadi. My metric number is 195456. Okay, so today let's see first. We have listened all the theory about the whirlpool turbine. So now let's see for the calculation. So this question asks about how much hydropower could generate from a whirlpool turbine for a typical small hydro system. The turbine efficiency that would be 85%, drive efficiency 95%, and generator efficiency 93%, with relative low gross head of 2.5 meters and a turbine that could take a maximum flow rate of 3 meter cube per second. Okay. Okay, first of all, the formula that's going to be used for this question is power P equal mg h net multiplied by the efficiency. So P, we all know P is a power. This one, M is a mass, G is the gravity, and these three is the basic that we all know. But the new one is the H net and the efficiency. So I'm gonna explain it out. What's it the H net? So the H net is the net of the head. This is the gross head physically measured at the site, less any head losses. To keep things simple, head loss. So we can, if we want to find the head H net, it can be H net equal to H gross multiplied by 0.9. And the last one is the efficiency. So the efficiency is the product of all the component efficiencies. All the component, we can combine all the efficiency, no need to separate each one of them, which are normally the turbine, drive, the system, and generator. Okay, first of all, we're gonna find the efficiency, which is this symbol. So like I said, go back to the question. Okay, for efficiency, like I said, we can combine by multiply all the efficiency, which is this one, 85%, 95%, and 93%. So first, so 85% is 0.85 multiplied by 93%, it is 0.93, and the last one, 95% is 0.95. When you calculate, you will get around 75.1% or 0.751. This is for the efficiency. So first we get efficiency, and the next one will be H net. So like I have mentioned before, the H net is H gross multiplied by 0.9. So from the question, we know that H gross is equal to 2.5. This one is the question given. Multiplied by 0.9, you will get around like 2.25 meters. So you get efficiency, you get H net, this one you get, this one you get. G you know is 9.81 meter per second square. The next one is, we want to know the mass. So from the question, the mass that given is 3 meter cube per second. So we are going to convert into liter per second. So eventually we don't have to convert anymore. So we just convert right now. So we will convert by multiply by 1000. So we will get, eventually we will get 3000 liter per second. Okay, so now you got all. You got M, you got G you know, H net you got, and efficiency you got already. So at the end, it will be P power that you want equal to 3000 multiplied by G you know is 9.81 multiplied by H net is 2.25 and multiplied by efficiency is 0.751. So when you multiply, you will get around 49,729 watt or 49.7 kilowatt. This is the hydropower that the Whirlpool turbine can generate from this percentage and from this H cross. And the next part, I'm going to present about the recommendation for improvement of the Whirlpool turbine. Okay, so first one of the recommendation that I have found is to don't use the Whirlpool for wound management. So because if we use the Whirlpool for the wound management, it will predispose and lead the patient to risk of bacterial cross-contamination, which means it will cause a lot of the bacteria inside of the turbine. And the second one, damage fragile tissue. And the second one is the damage fragile tissue from high turbine forces. Okay, this one, as my friend have mentioned before, that when the water go into the inlet and when it goes into the turbine, it will cause a lot of high power and high forces. So if we use the Whirlpool turbine with the wound management, a lot of some of the components that very sensitive might damage inside of the turbine, and it will cause a lot of problem until maybe we cannot fix it. And the last one, complication in extremity edema when arms and legs are treated in a dependent position in warm water. So this one, like the name, the wound management. So it might cause the disease of the water that called edema when our body touch the water. Okay, the second point. And the second of the recommendation is the cost-efficient mini hydro plant with low water head Whirlpool design methodology for rural areas or micro hydro Whirlpool power plants. Okay, this one is the development in mini hydropower production, and it is contributed to the near future distributed generation. This one is the new project for the odd engineer that's still going on and still testing. But it still causes some problem. So we'll see what's the problem for this one. So these are the problems which come in contact while implementing the power generation unit. Okay, first one is the high water head, and the second one, large flow of water. The third one, high cost of civil works, will cost a lot. The last one, large cover areas and its operation maintenance, it will cost. It will have to take very large area to build this one. Okay. Meanwhile, we still can fix all these problems by propose the simple Whirlpool turbine with the minimum of water head. Like I said, the problem is the very high of water head, so we will minimum it. And then minimum of water flow, minimum of cover area, portable design of basin with PVC and its robustness. So we will make the basin with the strongly of the PVC. And the last one, flexibility for the standalone and grid connected system. And the last recommendation that I have found is about the basic design, like my partner Kishore mentioned just now. Okay, first of all, the shape should be in a conical shape. The shape of the turbine should be in a conical shape. And the second one, the optimum number, the best number of the blade should be 4 or 5, not more than 5. And the third one, aluminum turbine blades are better than steel. Yes, because the steel can cause the rust when it touches with the water. And the last one for the basic design is the distance between the turbine sits and the top of the water vortex is where optimal height of the channel. This is like if this is the turbine on top and this is the water. So the distance between this one, we have to calculate to find the perfect distance to get the perfect height for the channel that water can flow in and then make the energy, then can flow out in the what's it called, in the perfect height. Okay. I think that is all from me and from our group. So okay, so for the conclusion, the whirlpool turbine system can be used for the rural areas up to 60 homes, and for the home that near the river, and the turbine system will create all the energy and then produce to that order up to 60 homes for 24 hours and 7 days non-stop. But for the big city or the large area, I'm not suggested to use the turbine system. I would suggest to use other of the turbine or other energy to create the energy. So I think that's all from us. Thank you very much. And if we have made any of mistaken or any something bad, so we are apologize from now, and hope to see you guys again. Thank you very much and see you.
So this is the small model of our whirlpool turbine system. So a close-up picture of this will be attached together with the soft copy. Thank you.
Thank you very much.